Blessed is the man who does not walk in the counsel of the wicked, or stand in the way of sinners, or sit in the seat of mockers, but his delight is in the law of the Lord, and on his law he meditates day and night. And he shall be like a tree planted by streams of water, which yields its fruit in season. His leaf also does not wither, and whatever he does prospers. Not so the wicked. They are like the chaff which the wind blows away. Therefore the wicked will not stand in the judgment, nor sinners in the assembly of the righteous. For the Lord watches over the way of the righteous, but the way of the wicked will perish. Okay, now remember, this is important. I leave for a soccer game. I leave for a soccer game Friday afternoon with the Lady Knights. If you are waiting until Friday afternoon to do your Bible verses, you have waited too late. So I am attesting right now. I will be here at lunch on Friday, and then I'm gone. All right, so do not wait around. If you have not done your Bible verses, don't wait around. Yes, Peter?
When are we leaving?
We're leaving after lunch sometime. I don't know exactly when.
Yeah, we should be leaving. Yeah.
Then don't count on lunch Bible verses. Okay. All right, here we go. This is called the inviolable argument. This is lesson 52. Now, what they're talking about when they talk about the inviolable, that's like impenetrable. You can't separate. All right? So, when we're talking about this, we have to keep that together until we can legitimately take them apart. Okay? We cannot pull out part of the argument of the tangent function, which means I can't come along and divide by 3, right? I can't come along and divide by 3 and get tangent theta. That is an illegal move. The only thing I can do is try to get my tangent by itself and then figure out what kind of argument would give me what I need. So the first thing we're going to do is get a 1 on the other side. So we're going to have tangent of 3 theta is equal to 1. Okay, so now I cannot separate this out, so I have to do some mental work. And I said, okay, on my unit circle, where is the tangent 1? And that's going to happen at what degrees? Did you say it? What was it?
I don't think it's
45s, right? At our 45s, because our 45s would be square root of 2 over square root of 2, square root of 2 over 2 over square root of 2 over 2. That's where our sine and our cosine are the same, is at 45s. So our tangent, which is our quotient of our sine and our cosine, is going to be 1 at the 45s. Okay, now notice we're talking about a positive 1. Where's the other place on our unit circle that we would have a positive 1 tangent? Ian?
The fourth quadrant.
Where is it? Third quadrant. The tangent is positive in the first and the third. You knew that, Ian. It's just early in the morning. I know that. All right. So we're talking 45 and what?
45.
Well, this 45 down after 180 is what? 225. So we're talking about the angles 45 and the angle 225 meet that qualification. But we don't have a theta equals to that. We've got a 3 theta equals to that, okay? So we have 3 theta is 45, and 3 theta is 225. And then we're going to divide by 3 on both sides, because now we've separated a function out, and now we have a linear. We have a linear equation here. 3 theta is 45. We divide by 3 on linear equations, and we can get our theta is what? 15. Theta is 225. That's going to go in 7 with 15, 5, 75. Did I do that right? Okay, so I've got 15 and 75. But wait! This says that theta can go all the way to 360. Because I'm dividing each one of these angles by 3 to get my theta, do you think I should keep going? In other words, if I made theta is less than 360, then 3 theta, which is what I'm really looking at, is going to go all the way to what? 3 theta should be less than 360 times 3. So what would 360 times 3 be?
1080.
Yeah, but I don't have to really worry about it. What I really need to do is go 3 trips around the circle. I don't need to worry about how many degrees that is. I'm going 3 trips around. I can keep on taking thetas for 3 trips around because I'm going to divide this by 3 to get my theta by itself. And if I go 3 trips around, I will still, once I divide by 3, I will still be in this range here, won't I? Okay, so actually that's my domain, my theta. Okay, so now I'm going to do what? I'm going to say, okay, let's take another trip around. So I go another trip. So I've gone 360 degrees, and I say, well, this is one of my, so 360 plus 45 is what? 405. So 3 theta could be 405. And then I come way over here and I add 225 to my 360.
585.
And I get a 585 is a 3 theta. And then I can go another trip around the circle. So now this little base is going to be 720 because I have made 2 trips around. And I'm going to add my 45 to my 720 and I'm going to get a 765. Right? And then I'm going to do what? Add 225 and I'm going to get 549. So I got 945 is 3 theta. Okay? Now let me make sure, since I've bounced off of here, that I am getting this on the picture. And I can't even type in my code. There we go. Okay, let me get this down so you can see that. All right, so we have gotten all of these. We have got 6 things because we had 2 per trip. And we were allowed to go 3 trips around because we're talking about a 3 theta instead of just a theta. All right. So now when I divide each one of these by 3, I'm going to get the actual theta. Okay. So I divided that. So somebody do 405 divided by 3. Somebody's got a calculator. Help me out.
135.
135. 585 divided by 3. Okay. Somebody work on each one of. Say what?
195.
195. Somebody do 765 divided by 3.
55.
765 divided by 3?
Yeah, 255.
Okay, 255. Thank you. And then somebody 945 divided by 3.
315.
315. Okay, so now we've got all of these are the answers to this problem. Okay, now let's do another one over here. All right, so this one, we've got this theta over 2 that is packed together as the argument of this function. Now, I've still got this as my, I'll erase this one now because that was the last problem. I've still got this as my theta limits here, okay? Now, if I'm looking at a theta over 2, and theta can go through 360, what do you think theta over 2 is going to do? Don't I have to cut that in half? So I'm only going to be able to collect my data for half the circle. So theta over 2 is going to go through 180. All right, so basically because I'm going to multiply by 2, I can only go through half a circle. Whereas over here, since I was going to divide by 3, I could go through 3 circles of data collecting. Over here, because I'm going to multiply by 2 to get my theta, I can only go through half of our unit circle to collect. So now I'm going to get this on the other side. So I have cosine theta over 2. I can't divide that out. Is equal to negative square root of 3 over 2. So now we're thinking, where is the cosine square root of 3 over 2 first? Okay, that's going to be with my 30s, isn't it? My cosine's going to be square root of 3 over 2 on my 30 reference angles, but it's going to be negative square root of 3 over 2 where? Here's my unit circle. It's going to be a 30 here and a 30 here. Because it's the cosine, it's going to be negative left, right? So we're going to have these two angles. But I'm only allowed to collect data through 180. Okay? So I'm only going to put this one in. And you're going to see if I did put this one in, so this is 150 and this one is 210. If I did put this one in and I said theta over 2 is 210 and then I multiplied by 2, what have I done? Gone outside the limit for my theta. So I can't collect data past the 180 mark. So I'm only going to have one answer here. Okay, so 150 is theta over 2. And then I multiply by 2. And my theta is what? 300. So that one only has one solution. Okay, let me get that one off.